Our purpose for finding determinants and for finding cofactors is so that we can use Cramer's rule to determine the solution to a system of equations. Now you're obviously going to get the same answers that you get when you use Gauss-Jordan, but the method for finding it is different. Notice we have our system at the top, and then let's skip down here to the bottom. If we have two variables and two equations in our system, then we need three determinants to solve it. The first determinant is made up of the coefficients. Notice A1, A2, B1, B2. Those are our coefficients of x, our coefficients of y. So that gives us determinant D. Now we need determinant sub x, D sub x. And what I've done is I've kept the y's, but in the x column, the x coefficients are going to be replaced with c sub 1, c sub 2, which are the constants. Then when I find d sub y, I'm going to put my x column back, and I'm going to replace my y column with those constants. Once I have d and d sub x and d sub y, then I can find x by dividing d sub x by d. That's what you see here. And y I can find by dividing d sub y by d. Now if I had three variables, three equations, then I could find z by taking d sub z and dividing by d. And however many variables and equations you have, you can use Cramer's rule to find that. Let's look at an example. This is a two-variable, two-equation system, and we want to use Cramer's rule to find it, to find the solution. So we need three determinants. We need d, we need d sub x, and we need d sub y. D, remember, is the determinant that's made up of just the coefficients of the variables. So 5 and 7, 6 and 8. I'm going to go ahead and set up my determinants, then I'll go back and evaluate them. To find d sub x, I want to take out my x column, and I want to replace that column with my constants column. So -1 and 1. The y column I'm going to leave alone. So for d sub x, replace the x column. On d sub y, I want to put my x column back in, 5 and 6, and I want to replace the y column with the constants, -1 and 1. So for d sub y, I replace the y column. Now let's go back and get numbers that these determinants represent. On d, if I multiply in this direction, I get 40 minus 6 times 7 is 42, so I get -2. D sub x, I multiply this direction, I get -8, minus 1 times 7 is 7, that's -15. For d sub y, 5 times 1 is equal to 5, minus 6 times -1 is -6, minus -6 is +6, so I get 11. Now that I have those numbers, I know that the solution to this system is an ordered pair. And the ordered pair is x, y. Well, to get x, I need d sub x divided by d. And to get the y value, I need d sub y divided by d. So I'm substituting numbers in that I just found. X is going to be -15, which is d sub x, divided by d, which is -2. And then y will be d sub y, which is 11, divided by d, which is 2. Now I do want to simplify here. A negative divided by a negative is positive. So really I could simplify that to 15/2 for my x value. Now Cramer's rule does not always work, and you can tell that it has a weakness because it involves fractions, and that weakness is the denominator of the fraction. If d is equal to 0, if I evaluate the determinant, which is the coefficient determinant, and I get 0, then Cramer's rule does not apply. It doesn't mean that there's no solution. It could mean that you have a dependent system where everything is a solution. So if Cramer's rule won't work, then you have to go to, if it fails because d equals 0, then you need to find another method to solve the system.